Hey everyone, myself Rohan, and today we are going to revise one of the most important language, which is TypeScript. So, what my plan is, before moving forward in my blockchain journey, I decided to revise TypeScript because in further projects we are going to use TypeScript only, not JavaScript. If you don't know, I am targeting to complete 5 projects in blockchain, one of which is already complete, which is an ICO platform. If you haven't watched, it's a 5-part video in which I have explained the working of Solidity, which I have written, and then I have integrated it with the front end. I have deployed the Solidity, and I have showed you how it works completely. And I've used Rainbow Kit and Walkman for integration. We'll be using that only, but next, a further process down the line, we are going to use TypeScript. So this is the best time to revise TypeScript. I'll make sure to cover each and every part of the important aspect of TypeScript. So let's understand what TypeScript really is. So it's an open source programming language which was developed by Microsoft, and it's pretty reliable language, you can say. And let's see how we can install it. First, we are going to create a file named test.typescript.ts, and here we are going to use for example, if you want to install TypeScript, you can directly use npm install-g TypeScript and it will be installed. And after that, you need a compiler to run the TypeScript, because TypeScript doesn't need it cannot be used in like your website. TypeScript only is needed for the developers in order to make sure the typecasting is perfectly used. So for example, I am using tsc TypeScript compiler --init for running TypeScript. Now we have config.json file here. In order for us to run TypeScript file, we need to change it to JavaScript, and for that we need to run one more code, which will be tsc test.ts, and we'll get a JavaScript file which we can directly run. But we'll make sure to make changes in TypeScript file first. So what will be the step? Let's understand the basics first. For example, you create a variable named id, right? Id can be a number or a string, abc, whatever. But you see, TypeScript by default understands what type you are giving based on the value you are providing. For example, currently I have this abc, which is a string, so it understood it as string. If I add 45, it will understand it as number. But we cannot let TypeScript assume anything predefinedly, so we have to make sure we add the type of the value, like the variable which we have. If we are placing number, we have to make sure to add number only. And if we want to console log, let's see, by console logging it, first we tsc.ts so that the TypeScript can be converted directly to JavaScript. And now we run test.js, not the TypeScript. It is 45. Similarly, if you want to add any other variable named name val, suppose, and it's a string, we add it to Rohan. If we want, we can directly console log it. If you want name val, right? First convert to TypeScript, then Node.js. This was the basic structure. If you want, there are other types also, like is true, it's a boolean type. If you want to add a boolean type, you can directly add it. If you directly add it here only, is true equals to boolean, it will assume that it's a boolean. I mean, sorry, not bool but false. It will assume that this is a boolean type. You can see it here. But we should not allow TypeScript to assume anything beforehand, right? Now, simple variable is not the only thing. You can also add a array of variables. For example, if we add, let array var is 1 2 3 4 5, right? It's a array of type number. How you gonna define an array of type number? Like this, number and brackets. That's how you define an array of numbers. Now it can be a string also. For example, if you want it to be string, it will call you an error. Sorry, not here, but the type should be changed, string, and it will be an error. The red squiggly lines which will define the error, which is type number is not assignable to type string. You can change it. For example, this is one of the string array, whatever, right? Now there's one more type. If you don't know the type, what you can add is you can use type any. For example, if you have a val whose type you are not quite aware, it could be a string also, it could be a number, or it could be a boolean, anything. So if you add a type of any, everything will work here. For example, a boolean will also work. If you add a string, it will also work. If you add a number, that will also work. If you don't see any red squiggly line, it means it's working. That's it. And same is okay with an array also. For example, an array of any, and we add a bracket, we can have any value inside this array. This is a number. If we add a string, that will also work. If we add a boolean, sorry, not a boolean but a boolean value, that will also work. I hope I'm clear up until now. Let's move forward. What we have, let's understand the function, how it works, right? For example, we have a function const combine values, and it takes two values, a comma b, and what it does is it returns a plus b. Cool. And if I run, you see he is asking, the TypeScript is asking, we have to define it, otherwise it has implicitly, like by default, it has type any, which should not happen. Like we should have a proper naming and a proper type definitions for each and every type which we are using. So what if we call or console log combine values and we pass 4 comma 5, and similarly if we pass hey there, right? We want to see what happens. If it was JavaScript, the value would have been simply a plus b, 5 plus 4, 9, and here it would have concatenated it, because it quite naturally understands, the JavaScript naturally understands that this is a type of string and this is a type of number. But here is where the real deal is. Like you cannot implicitly expect that if you are expecting this to be a string, then by default this function should only take string values if we want. But here we are getting numbers and it's not causing any errors, which is wrong. Like if you are defining a type, you should get some errors for that also. For example, let's call it now and test it. We are going to compile the TypeScript file and then we are going to call node.ts. See, it is taking this as number and this as string, which is wrong. Like it should have the capability to cause error or tell us that this is wrong, please expect, we are expecting either a string because we are concatenating these values, or we are expecting a number. In order for you to put in the values in the argument, you have to separately use a colon and add string here, and then again string, for example, you get it. And we'll have a issue that argument of number is not assignable to type string. Now that's what we were expecting. We need errors if the values don't play by the rules which we defined. That's what TypeScript is for. So if we added numbers and numbers, this will cause issues. This is causing error. So I hope I'm clear. Now one more thing, if we want to return some other value, for example string value returned. See, if we want to add a fixed situation where we only need a certain value to be returned, a certain value of certain type to be returned, we have to put the value to the return type also. For example, we need a number to be returned, not the string, so we need to put the type of the return type also. How we are going to do that? We are going to do this like here. If we added number as a return type, it is expecting for a number to be returned. For example, a plus b works fine because a is also number, b is also number, combined value is also number. Now it's working. That's why the return type can also be defined in order for us to make a strict rule that return type should be a number here. Now if we move forward, we can understand how TypeScript works for an object also. Let's understand that TypeScript works for an object. For example, we have a user of name Rohan. Name is of type string, age is of type number. What else? Name, age, ID. Let's see the ID. ID is also type number. Now by default, it is defined that name is of type string, age is number, and ID is also number. But what we learned is we should not allow TypeScript to assume anything. So let's define the types also. How we will define the type of an object? For defining the type of an object, we use a type named interface user type, right? And now we are going to define name as a string, age as a number, and ID as also a number. Number. I think I'm clear. And this user type should be added here. User is user type. I hope I'm clear. So moving forward, we also have a situation where an object has certain fields which the user does not want to give. For example, if you are fetching some data and that data, certain data is an array of objects, and a particular object does not have a type named age, and if we remove age for certain area, like for any value, if we remove age, it will cause an error like age is missing in the type. So it is optional how you are going to make a property of an object as optional. We are going to use a question mark, for example here. All issue is cleared. If there is a question mark, it means this age type is optional. You can add it, for example age 56, and it won't cause an issue, and you can remove it also, it won't cause an issue. So this was type, and with there are multiple types also here. And if you want to like understand how we use functions and types, let's understand that also. For example, this user has a function named call function, right? And it console logs, hey there, it's me, right? But this is not defined in the interface. How are you going to define it? Let's see. We'll give the name of the function, call function, and it will be of type. We are going to type it as the return value. Like if it does not return something, for example here, if we are not returning anything, we are just console logging, we will just return it as void. Here we have to call it like this also. This is the way we define any function. If it returns, for example, if it used to return something like number, like 0, we should have written here number. I hope I'm clear. So that was for the function, the objects, and how we use objects of multiple types. Now, if you want to add something like unions for any values, how you gonna use it? We are going to, for example, we have a function greetings, and we have a value which has been passed here, and what we are going to return is val only. Okay, makes sense. What happens is, if you want this value to be either a number or a string, how you're going to like define it in this? We are going to use union types. For example, if we add string and we are calling this greetings as 45, it won't work. We'll get the red squiggly lines of things which says that argument of type number is not assignable to type string. And if we call it as string, then only it will work. But if we want either a number to be like valid or a string also to be valid, we have to add a union which can include both of them, either a string or a number. If we add string also, it will work. If we add greetings also, it will work. So if let's console log it and check it out. Right, sorry, let's console log it and check it out. Node, first we'll compile it, then node test, it's 45. If we added only 45, let's see, psc, compile it, run it, it's a number. So both will work. This was union of two types, right? Next is the intersection. For example, let's understand the intersection. How? For example, you have a object const employee, right? He has a name of Rohan, and no, let's not go into this. Let's define two types, right? Interface, two types for an object, then we'll use interface. Employee type of name as a string, will be having string, age will be of type number. We have another object type which will define it as human type, right? What we are going to add, gender as a string, and let's add a bool, which is good person, random, which will be a boolean. All right. So if we have uh, an object like an object named random object, which has a type, which has a type of intersection of these two, which will be employee type and ampersand and human type. It will contain both these values. It should contain both of these values. That's what intersection means. Union was meant to be the like any value among the two will work. Like we had a string or a number, any of the two will work. Here we need both of the values. For example, if I add name and age for the employee type in the random object, name as Rohan and age as 65, it will still cause error. Why? Because employee type and human type is still left. If we add gender to be male, it's a string because one of them is still left, is good person, bool false. I hope, see, it's now we are not having any red squiggly lines. Why? Because we are having intersection of both of them, right? I hope I'm clear. And now if this is very lengthy for you to write both of them as the intersection, you can create your own type. How? By using a word named type. My own type, which will be an intersection of employee type and human type, and you can add it directly here only. My own type. Now it's all clear. I hope I'm clear with everything which I am explaining you right now. And the interface is also ready, the intersection types, the union types is also ready. Now I think we should discuss enums, right? So where do we use enums? That's a place, like there's a separate place where I have used a lot. For example, I have a function which shows error messages, right? Const error messages equals any error message which we can show will be like error which was passed here. Let's see. Right now the error can be of many types. We can define that error types. For example, if we type it here only, error messages can be, let me comment it out, error messages can be of unauthorized and what could be like internal server error, user doesn't exist, anything like that only. I mean, if the user added something wrong, then wrong credentials, whatever. So if we want to define all of these values separately, we can create an enum. How we're gonna do that? Suppose we create an enum of named enum messages, right? The format is similar to type of interface. For example, now if I create first enum would be unauthorized, and we'll be having a value for this key will be, let's keep it simple here only like this. We're not sorry, we don't do it like this, we do it like this. So first was unauthorized, let's add internal. It will be like sir, we're giving it just key and the value pairs, for example, like that only. Server error, right? Then we'll be having not available. Yeah, it will work. Does not exists, yeah. And last will be wrong credentials. Same, wrong credentials. Yeah. So if we define this error as this value enum messages, what will happen is we can use if else statement to define a separate statement for each error type. For example, if we want to define unauthorized, you're not the correct user, we can directly use unauthorized. For example, I'll show you. If error equals enum messages dot unauthorized, we can console log unauthorized, you're not the user, right? Else if, let me write 4 of them first. Else, right, makes sense. So if it is unauthorized, it was there. Now if it is internal, if it is not available, if we are having wrong credentials, will show different errors. For unauthorized we have this. For internal will show internal server error. Now will show not available, and for wrong credentials will again show wrong credentials entered by the user. Make sense? If so, now that was not the only part. For example, if you want to call this function, if you want to console log the error messages, not directly like console log, if you directly want to call this error message and we call out as like we're passing enum message dot let's say internal, let's see what happens. First we'll compile it, then we'll run it. See, internal server error, something which was here. If you want to call wrong credentials, it makes developers' life much simpler so as to type these values separately. Like we can directly pass on wrong credentials and the statement will be delivered. First we compile it and then we run it. See, wrong credentials entered by the user. So these were the things up until now which is important in order for us to revise TypeScript and use it in our future use cases for integrating and further process. I believe this is till now which we have revised. I think this will only be used, nothing more than this can be used. If it will be, we'll go through it at that point only. And comment down your thoughts of how you found this video, and if you found this video informative, make sure to like and subscribe, and yeah, comment down your thoughts on how I can improve more. And this was pretty much it for the revision of TypeScript. And if you have anything or if you face any kind of errors or problems, you can comment down your problems in the comment section only, and let me know your thoughts. And yeah, follow for more.